What would happen if electricity disappeared for 24 hours? No lights, no internet, no water, no fuel. No fuel. Hospitals in emergency mode. Supermarkets empty. Entire cities paralyzed. And the most disturbing part, it would happen much faster than you think. Because modern systems don't collapse slowly. They collapse suddenly. Electricity feels simple. You flip a switch, and it works. Every time. No delay. No effort. No thought. Behind that simple action is one of the most complex systems ever built. An invisible network connecting power plants, cities, industries, and billions of people. And there's something most people don't realize. This system cannot stop. Not even for a second. Because electricity is not like water. It cannot be stored easily. It must be produced exactly when you use it. Every second. And if that balance breaks, even for a moment, the consequences can spread faster than any human reaction. Electricity doesn't come from the wall. It begins in power plants. Coal, gas die, nuclear die, hydro, wind die, solar, different technologies. Same principle. Something spins. That motion drives a turbine. The turbine drives a generator. And the generator converts motion into electrical energy. It sounds simple, but every source has limits. Coal and gas plants are controllable. You can increase or decrease output when needed. Nuclear plants are stable, but slow to adjust. Hydropower is flexible, but depends on water availability. Wind and solar are clean, but unpredictable. The sun doesn't always shine. The wind doesn't always blow. And this creates a fundamental challenge. Electricity must be reliable, but not all sources are. Which means the system must constantly adapt. Every second. Generating electricity is only the beginning. The real challenge is moving it. This is where the grid comes in. One of the largest machines ever built by humans. Electricity leaves power plants at extremely high voltage. Hundreds of thousands of volts. Why? Because higher voltage means lower current. And lower current means less energy lost as heat. This allows electricity to travel long distances efficiently. That's why you see massive transmission towers. Crossing mountains. Crossing rivers. Crossing entire countries. They are not just infrastructure. They are the backbone of modern civilization. Electricity travels hundreds of kilometers, from power plants to substations, where voltage is transformed, step by step. High voltage, medium voltage, low voltage, until it finally reaches your home. But here's something most people don't know. The grid is not just wires. It's a synchronized system. Every generator connected to it must spin at the same frequency. In Europe, 50 Hz. In the US, 60 Hz. Perfectly synchronized. Across entire continents. And maintaining that is incredibly difficult. This is where things become critical. Electricity is extremely difficult to store. Large-scale batteries exist, but they are limited. So most of the time, electricity is used the moment it is produced, which means supply and demand must stay perfectly balanced. Every second. If demand increases, generation must increase instantly. If demand drops, generation must decrease. If not, the system begins to destabilize, and the first sign is frequency. That 50 Hz is not just a number, it's a signal. If it drops to 49, the system is under stress. If it rises above 50, there is excess generation. And if it moves too far, automatic protections activate. Power plants disconnect. Lines shut down. Sections of the grid isolate themselves to survive. But sometimes, those protections make things worse because the system starts breaking into pieces. And that's when failures begin to cascade. A small failure can become massive. It doesn't happen all at once. It happens step by step. One transmission line fails. The electricity doesn't stop. It has to go somewhere. So the load shifts to another line. That line wasn't designed for it. It overheats. And then it fails too. Now the system is under pressure. And every failure increases the stress on the rest. This is called a cascading failure. And once it starts, it's extremely difficult to stop. In 2003, this is exactly what happened. A tree made contact with a power line in Ohio. A small event, almost insignificant, but the system didn't respond correctly. Alarms failed. Operators didn't see the problem in time. The load shifted. More lines failed. And then the cascade began. Within minutes, multiple states were affected. Within hours, over 50 million people lost power. Entire cities went dark. Traffic lights stopped. Subways froze underground. Elevators trapped people inside. Fuel pumps stopped working. Communication systems. And the most important part, this didn't take days. It happened fast. Faster than people could react. Because complex systems don't fail gradually. They fail suddenly. The system is under more pressure than ever. We are using more electricity, and we are using it differently. Electric vehicles, data centers, artificial intelligence, electric heating. Everything is becoming electric. At the same time, we are changing how we produce energy. Solar and wind are growing rapidly, but they introduce variability, which makes balance. This is why storage is becoming critical. Large battery systems, grid-scale storage, new technologies, and this is also why smart grids are being developed. Systems that can react in real time, adjust automatically, predict demand, and redistribute energy instantly. Because the future grid must be faster, smarter, and more adaptive than ever before. Most people never think about electricity because it works until it doesn't. And when it fails, everything else fails with it. After 1 hour, traffic becomes chaos. After a few hours, communications start breaking down. After 12 hours, water systems begin to struggle. After 24 hours, food supply chains are disrupted. Hospitals rely on backup systems, but even those are limited. And the longer it lasts, the harder it becomes to recover. Because modern society is built on one assumption, that electricity is always there. And when that assumption breaks, so does everything connected to it. Electricity is one of the most powerful systems humanity has ever built. Invisible, precise, fragile. Every second, it keeps the modern world alive. A system in perfect balance. Constantly adjusting, constantly under pressure. And yet, almost no one notices it until the moment it stops. This is System Decode.